Okay, we're going to talk about compound interest. So, compound interest, this is where you earn interest on the original principal and previous interest. Okay? So it depends on what side of the loan you're on, but interest is the cost to borrow money. Okay, not everybody has $1 million sitting in a bank, so they have to go out and borrow money if they want to buy a car or a house or, a really fancy dog or whatever, right? So when you go and you borrow that money, you don't just go say, "Hey, bank, I need $20,000." They say, "Oh, here's $20,000. There you go," right? And all you have to pay us back is 20,000 bucks. That's not how it works. They say you got to pay us back 20,000 bucks, that original principal, along with interest on that. So maybe the whole loan over the life of the loan ends up being 30,000 or 40,000, depending on what you're talking about. Typically, house loans, mortgages, if you buy a $200,000 house and you spread it out over 30 years, you're going to end up paying about 400,000 over that 30 years. Okay, so that is the cost of borrowing money, interest. Welcome to the real world. So, interest can be a good thing. How can interest be good? If you're investing money money in various ways, so in the stock market and bonds and corporate debt, whatever, right? Letting your buddy borrow $1,000 and you say, "Look, you got to pay me $1,100 back after you get done borrowing this money," right? It can be from big to little. In the bad sense, compound interest is bad with credit cards. So credit card debt is a huge problem in America. Government statistics, average credit card debt per household in America is extremely high. Okay, so you're talking about some big bucks going on there. Car loans, mortgages, you know, at the end of the day, if you're strapped for cash and you got to pay for something, either you got the money or you're going to have to put it on a credit card. So, credit cards have their uses, but as long as you pay them off, it can get really bad for you. You're talking about 18% debt or 18% interest on $50,000 balance, even if it's an average, a $10,000 balance, right? So a $10,000 balance, 18%, you're talking about a good chunk of money, $1,800 a year that you're not even going to pay towards how much you owe, but that's just the cost to borrow. That's the interest. So things can add up pretty quickly when you're talking about credit cards and interest. They slip you in and they say, "Look, guys, we'll give you this money for free for the first 18 months." And then all of a sudden the 18th month rolls around and you've racked up $10,000 in credit card debt, and boom, they got you. You can't pay off $10,000 in 1 month. So now you're all of a sudden paying interest on this, and it gets really bad really fast. Okay? So if you got to borrow money, try to pay it off as fast as you can, right? Student loan debt's one of those few debts that will never go away. No matter, even if you file bankruptcy, you're going to be stuck with that booger for the rest of your life. So might as well start paying it off now. Okay, so an investment of P dollars at an annual interest rate of R, compounded N times per year, has an accumulated value after T years of, well, this formula is the future value of your investment or debt or whatever it is, A of t, which is P times 1 plus R divided by N raised to the N times T. Okay? This is a formula. You need to write this formula down. You're going to have to use this formula on your exam, so make sure you know how to use that formula for future value. Okay. Now, one thing I want you to note, so this is for compound. You see the word compounded n times, you use this type of formula. Now, compounding, so if I had a compound n equal to 1, that's annually. That means once a year. N equal to 2 compounding is semi-annual. N equal to 4 is quarterly. N equal to 12, that's monthly. Right? Daily is N equal to 365. Okay, weekly. We're just going to use for 1 week, we'll say N equal to 7 for 7 days, okay? Now, there's a note here, like this can just keep getting higher and higher and higher, right? So we could do daily, hourly, minute, second, and so on. So as N goes off to infinity, something's happening here, okay? Here's what's happening. Basically, you're taking this limit as N goes to infinity of this number plus 1 over that number raised to the N. This limit, if you take this limit, if you compound continuously every millisecond of every little millisecond forever and ever, you get this number E. This E is a very special exponential number, okay? It pops up in nature a lot, right? So this E here is used for this second scenario. So if I have P dollars invested for T years in a continuously compounding continuously compound account with an annual interest rate R, the accumulation is A of t equals P times E to the RT. Okay? So your base is E raised to the RT. That's the reason the base is the E is this reasoning that I was talking about here. You don't have to understand that. You just need to know the formula here. Okay, you don't need to understand why the vehicle works when you turn the key. You just need to know how to turn the key, right? Okay, so Sarah invests $10,000 in a savings account that earns 3.5% annual interest compounded quarterly. Now, good luck trying to find a savings account that earns 3.5% interest. Now, at the Fed funds rate, they've slashed rates down to 0 as of 2020. After this old coronavirus, they slashed our rates down to 0. Make people where they don't want to save any money because basically they're going to be losing money due to inflation. So annual interest compounded quarterly tells me N compounds, quarterly means 4. What is the value of her investment after 4.5 years? 4.5 years, this is going to be what? This is going to be T equal to 4.5. The initial investment is my P, and my rate is 3.5%, which is 0.035 in decimal form. Okay, so I get all my numbers. I think I got everything I needed. Now, how do I know which formula to use? I see the compounded, right? That tells me I'm using the formula A of t equals P 1 plus R over N NT. So P is 10,000. There's 1 plus R 0.035 over 4 compounded quarterly. And then I have 4 times 4.5 up here. So I can type that into my calculator. So 10,000 times parentheses 1 plus 0.035 divided by 4. And then outside my parentheses, raise it to the exponent of 4 times 4.5. And then I hit enter. And so I get 11,697 and 79 cents. Why do I round 2 decimals? Because I'm talking about money here. So round to units that make sense. Ha ha ha, cents, get it? Okay, sorry. I have to control myself on my corny jokes. All right, so the amount of money that Sarah will have after 4.5 years is 11,697. How much money did she make? By doing nothing but putting her money in a bank, the money made, let's see, well, 11,697.79 minus 10,000. The money made how much? 1,697.79. That's not bad for just sitting money in a bank account. That's not bad at all, right? So a savings account giving you that much in 4.5 years, that's pretty amazing. Okay. Now, instead of investing that money in an account that compounded 4 times a year, the more times we compound, the more money we make, right? So like credit card debt, you think about that, that's compounded every month. Every month you get the credit card debt. You got to pay a little bit on your bill, right? So it's compounded every month, monthly, that's 12 times a year. The more times you compound, the worse it gets for you. So if I compound continuously, that's going to be pretty bad, right? Well, let's see. P is still 10,000. Compounding continuously tells me that P of T, or let's see, what was our formula? Did we use A? Yeah, A of T equals P e to the RT, right? So I got P, I need R. R is 0.035, that's right there still. And T, how long? 4.5 years, so T is 4.5. So I plug in 4.5 for T, and I get 10,000 times e to the 0.035 times 4.5. Type it in your calculator. How do I do that? Go to your calculator. 10,000 times second, and then the ln button gets you the e. And then what did I have? I had 0.035 times 4.5. Enter. Oh my goodness, that's really close to compounding quarterly. That's interesting. I was thinking it'd be a whole lot further off. Well, guess what? After you get out past a certain amount, it's not as big of a deal anymore. Okay, so really after compounding monthly, you're starting to get to a point where you're gonna look like a vampire if you're making your people who owe you money pay up weekly or monthly, more than monthly, right? So, and it really doesn't contribute a whole lot more. So that's $11,705.81. So 11,705.81. Okay. So this account earned 8.02 more than the quarterly compounded account. So you might see a question in your future that, it says something like, why did this account earn more than the other? So 2 reasons. typically you're going to run into. One of the reasons is maybe one of the interest rates was higher than the other interest rate. For this particular problem, our interest rate was the same, 3.5 for both problems. So that's not a reason there. But the other reason why this one earned a little bit more is because you're compounding continuously. You're doing more compounds than you are when you're compounding quarterly, okay? So quarterly, you only compounded 4 times. Continuously, you're just compounding infinite amount of times. So reasoning for why you earned more money, you're compounding more. That's one reason. That's the reason for this one. For another problem, it could be, you were compounding more and your interest rate was higher or whatever, okay? So that's something to keep in mind as you work through those problems. One thing to note, all exponential functions can be expressed as f of t equals a naught, some initial starting, times e to the kt. Okay, so e to the kt. All right, now a naught, this is the initial amount. K depends on the growth rate. If k is greater than 0, we're talking about a growth function. Okay? If k is negative, it's less than 0, this is a decay exponential function. Okay? So if k is positive, that's a growth. If it's negative, it's a decay. And t is just the time. Okay, t is always your time. All right, so that's what's going on there. So we talked earlier about carbon-14. Carbon-14 has an A of t equal to A0 times 0.999879 to the t. But we can rewrite this as this form here, and to do that, you would get A naught e to the negative 0.000121 t. Okay, so you don't need to know how to do this. You just need to know that you can write any exponential in the form A naught e to the kt. Okay, so that's just something to note there for you. All right. Now we've got two more problems. Okay, so this one right here, we've got Jamal who wants to earn $1,000 in interest in 2.5 years off of the $21,000 he's already got to invest. To decide if this is even possible to do, he wants to invest in some account that compounds semi-annually. He needs to figure out the interest rate for such an account to meet his goal. So what is he looking for? The annual interest rate. He wants to know what is R. Okay, that's what he wants to know. If I'm talking about compounding, I'm using my formula. AT equals P 1 plus R over N to the NT. So what do I need? I need to know what AT is. I need to know what P is. I need to know what N is. And I need to know what T is. And I'm going to solve for R. So this first thing here, Jamal wants to earn $1,000. I want to make that amount of money. Okay, so if I earn $1,000 on my $21,000, how much money will I have in the future? I will have $22,000. So the future amount is $22,000. How much money do I start with? My principal, that's $21,000. Okay, how many compounding periods? Semi-annually is twice a year. How much time do I want to pass? Only 2.5 years to go by. So let's plug in the numbers, see if we can solve. So let me erase that scratch work there so I'll have room. So I got 22,000 equals 21,000 times 1 plus r over 2 to the 2 times 2.5. So what is this? Divide both sides by 21,000. Okay. So that's like 22 over 21 equals what? 1 plus r over 2 to the 5. How do I get rid of a fifth root or a fifth power? I take the fifth root of both sides. So what does this get me? Oh my goodness, the fifth root of 22 over 21. Type it in your calculator. Okay, parenthesis, oh, that's not right. All right, parentheses 22 divided by 21. Close it, raise it to the fifth root, so that's 1 divided by 5, right? So this number right here, 1.009, we're just 1.009. We're going to keep it in our calculator so that we don't get a rounding error. What do I do now? Minus 1, minus 1. So subtract 1. Oh my gosh. Oh man. 1.00934741199 minus 1. Enter. Okay. So 0.09009 roughly. And that's r over 2 multiplied by 2 multiplied by 2. And so r is what? Times your answer by 2. It's 0.01869. 0.01869. So if you walk up to somebody like, your answer is 0.01869, they're going to be like, what? But if you move your decimal over twice, 1, 2, you're going to get a percentage. So 1.869%. Okay, so 1.869%. Good, I rounded okay. All right, so this is like 1.87% rate going on here. That's the rate that you need in your account to make this, which is possible through a money market account. Okay, so a money market account, you could get this right here, potentially. Okay, so last question, we're talking about the half-life. And here's a problem that confuses a lot of students. But when we're talking about the half-life, that's how much time it takes for half of whatever the element is to disappear. So we're talking about element here, element X here, that's like, X-Men or whatever. So approximately 42 days for half of element X to disappear. So it's a pretty quick half-life. I want to figure out A so that this function models my element X, how much is left after T days. Okay, so how do I do this? Well, I know at 0 days, I'm going to have A naught, A to the 0, which is just A naught. So that's the initial amount. Okay. And then after 42 days, how much do I have left of the initial amount? How much do I have left of the initial amount? Well, I only have half of my initial amount left. Okay. So if I'm going to solve for A here, what am I going to do? I'm going to divide both sides by A naught, and the A naughts cancel. And so basically what I get is 1/2 equals A to the 42. Now what I want you to notice, and a little trick for you guys that are paying attention, if I'm talking about half-life, the only thing I got to do to find my A is set 1/2 equal to A raised to whatever the half-life is. And that's it. And now I solve for A. I take the 42nd root of 1/2. So A is roughly 1/2 raised to the 1 over 42. And when I type that into my calculator, I'm going to get 0.983 10.363. Okay, so go out like 5 decimals is what they tell you to do. So what does that tell me? My A of T model is what? It's A naught times 0.98363 raised to the T. That's my model. Okay? How much of a 12-gram substance of element X would remain after 1 week? So how much of a 12-gram substance will remain after 1 week? Do I put 1 in here for my time? No. What was it in terms of? It was the half-life was in terms of days. So 1 week is T equal to 7 days. So it's 7 here, okay? So this is A naught, which is what? A naught is 12 grams. That's what I started with of element X. And then my A was 0.98363. And then how long? T equal to 7. So I type this in my calculator and I get 10.69 grams. Okay? So that is how much is left after 1 week. I go from 12 grams down to 10.69. All right, that's going to end